Section 7.1, completing the square. We're going to take what we learned in Chapter 6 as to how to solve equations with an x squared, and now we're going to take it up a notch by solving quadratic equations by using this technique. So how do we solve quadratic equations by completing the square? This is standard 8. Here we go. If x squared equals r, then as we learned in Chapter 6, x has to equal the plus or minus square root of r. So you can now solve for values of x that are part of binomials, and the best way to show this is to take a look at an example. So we have x plus 3 quantity squared equals 5. By taking the square root of both sides, don't forget you need to have the plus or minus square root on the right. So x plus 3 is now equal to plus or minus the square root of 5. Now, if you were solving for x, you would just subtract 3 from both sides, so you're left with x equals negative 3 plus or minus radical 5. And those two represent the two answers in your solution set. Negative 3 minus root 5, negative 3 plus root 5. So when you have a binomial, take the square root of both sides just like you did before, making sure you have the plus or minus square root of the number on the right, and then solve for x by adding or subtracting whatever value is alongside the x. Example 2, f minus 12 quantity squared equals negative 18. Go ahead and try this one yourself. Don't forget you can have imaginary numbers in your answer. Alright, so if you've taken the square root of both sides, you get f minus 12 equals plus or minus the square root of negative 18. Don't forget you'll now have to take the negative out of the radical, and if you add 12 to both sides, you get f equals 12 plus or minus I radical 18. Well, now you just have to simplify the radical 18, and when you do that, you should get f equals 12 plus or minus 3I root 2. And those represent your two answers. Don't forget to put them in a solution set. 12 minus 3I root 2, 12 plus 3I root 2. Alright, number 3. You have that expression. Go ahead and try to solve this one yourself. The goal is to get the 5 minus x quantity squared on one side all by itself. Move everything else to the right. Alright, so the first thing I did was multiply both sides by 4. 3 times 5 minus x quantity squared plus 1 equals 28. Subtract 1 from both sides and divide both sides by 3. You get 5 minus x quantity squared equals 9. Now you can take the square root of both sides, so you have 5 minus x equals plus or minus 3. Now if you add x to both sides, you get x equals 5 plus or minus 3. If you subtract or add the 3 to both sides, you pretty much keep the plus or minus, so it doesn't really change anything. So x is equal to 5 plus or minus 3. So your answers are 2 and 8. The other way to do this, to think about this, is 5 minus x equals 3, or 5 minus x equals negative 3. So you could do it that way instead of doing it this way. Number 4, we have x squared minus 4x plus 4 equals negative 2. Go ahead and try to solve this one yourself, keeping in mind you'll want to factor or simplify the expression on the left. Alright, so if you simplify the expression on the left, you get x minus 2 quantity squared equals negative 2. Now you're ready to take the square root of both sides, and you get x minus 2 equals the plus or minus square root of negative 2. Pull out the I and add 2 to both sides, and your answer is 2 minus I root 2 and 2 plus I root 2. So, for a question like this, you're going to have to factor. Hopefully you have a perfect square. Once you do, take the square root of both sides just like you did before, and at the end simplify for x. Alright, we're going to now show you how to complete the square. This is a way to change a quadratic equation so that you can create a perfect trinomial square on the left side. This is called completing the square. So, there are 5 steps to how to do this. The first step is to transform the equation so that the constant term c is all alone on the right side. So you're going to move everything over to the right. That's a number. You're going to leave any x squares and x's on the left. Step 2, if a, which is the coefficient of the second degree term, is not equal to 1, then divide both sides by a. So if you have an x squared as the first term, you're all set. But if you have a 2x squared or a 3x squared or whatever, you're going to have to divide both sides to get that coefficient out so that you make it an x squared instead of a 2 or 3x squared. Step 3, add the square of half the coefficient of the first degree term, b over 2a quantity squared, to both sides. So basically what you're going to do is add b over 2a quantity squared to both sides of the term. Number 4, we're going to factor the left side as the square of a binomial, because once you do that, once you get x squared plus b over ax plus b over 2a quantity squared, you are going to have a perfect square on the left. You can factor it as a perfect square. Finally, complete the solution using the fact that x plus q quantity squared equals r is equivalent to x plus q equals plus or minus the square root of r. That's basically what we did in examples 1, 2, 3, and 4. So let's take a look at how this works in an example. Example 5, solve by completing the squares. So let's go ahead and walk through the 5 steps. The first step is to move all the constants to the right side. So we subtract both sides by 13, and this is what you end up with. Now, you don't have to worry about step 2 because a, the coefficient of x squared, is 1. So you can move straight on to step 3. Step 3 tells you to take b divided by 2a and square it. So a is 1, so 6 is the b term. 6 divided by 2 is 3. Square 3 and you get plus 9. Now you're going to add plus 9 to both sides of the equation. Step 4, rewrite the trinomial as a binomial. So this becomes x plus 3 squared. You simplify the right side to get negative 4. Now this problem looks just like the first 4 examples that we just went through. So let's take the square root of both sides, and you get x plus 3 equals plus or minus the square root of negative 4. And again, you'll want to take the I out of the negative 4, so it becomes I root 4. X is negative 3 plus I root 4. Now take the square root of the 4 to get 2. So x is negative 3 plus or minus 2i. And those are your 2 answers. So you've seen the 5 steps. First, move all the constants to the right side. 2, divide out the a to make sure that the coefficient of x squared is 1. Add the square of half the coefficient of the first degree term, which is b over 2a quantity squared, to both sides. Then factor the left as a trinomial, and then take the square root and write down your solutions. Let's go ahead and try this one. A squared minus 5a plus 3 equals 0. I would encourage you to attempt this yourself, and you can check back in when you're ready. Alright, so let's move the 3 to the right side, so you get a squared minus 5a equals negative 3. Now, you don't have to worry about step 2 because we have a 1, or an imaginary 1 in front of the a squared. Now you will take half of b, which is negative 5 halves, multiplying it by a, 5, so it's negative 5 over 2 squared, which is 25 fourths. And now you have to add 25 fourths to both sides. Again, you're going to square negative 5 over 2, which is negative 5 halves. Square root of negative 5 halves is 25 fourths. Add that to both sides. Now simplify, and you will see that this is a minus 5 halves squared. This equals 13 fourths. Now you will take the square root of both sides to get a minus 5 halves equals plus or minus the square root of 13 over 2. And now add 5 halves to both sides, and you get 5 plus or minus the square root of 13 over 2, and write your answer as a solution set. 5 minus root 13 over 2, and 5 plus root 13 over 2. So sometimes you're not going to get pretty answers. Sometimes you're going to get fractions. That's part of dealing with completing the square. 7x squared minus 8x plus 3 equals 0. So let's walk through this one, just because we now have a coefficient of the x squared. So first step remains the same. Take the plus 3 on the left, move it to the right. Now you're going to divide all terms by 7 so that you get rid of the coefficient of the x squared term. So x squared minus 8 sevenths is x equals negative 3 sevenths. Now again, take half of the b term and square it. So you get negative 8 fourteenths, or 8 fourteenths squared. and you're going to add that to both sides. If you simplify that, you get x minus 4/7 squared equals negative 7 times 3 plus 16 all over 49. I reduced this and I put it all together. You can do this on your own if you want. And if you simplify that, you get x minus 4 roots over 7 equals plus or minus square root of negative 5 over 7. This is negative 21 plus 16, or negative 5. Square root of 49 and 7, square root of negative 5 is up there. Now you add 4/7 to both sides to get your answer. 4 plus or minus I root 5 all over 7, and write your answer as a solution set. If you're having problems understanding where some of these come from and how we get from each step to each step, please ask me during class. Most of you should be able to see what steps I'm doing. So here I add 4/7 to both sides. Since both of them have a 7 in the denominator, I can combine the numerators up top here. Go ahead and try this one yourself. We have a 9x squared equals 36x minus 35. Follow the 5-step plan and see where you are in a moment. So we'll subtract the 36x and move it to the left side. So we get 9x squared minus 36x equals negative 35. Again, let's divide both sides by 9 to get the x squared with a coefficient of 1. And you see what the result is. Now you complete the square. You're going to basically take 4 over 2, or 2 squared, that goes here, and that's going to be added to both sides. I just showed it to you how formal it is. If you've seen this pattern enough, you'll know you're going to add 4. So let's add 4 to the right side, and you get x minus 2 quantity squared on the left equals negative 35 plus 36 over 9 on the right. Well, that equals to 1/9. So if you square root both sides, you get x minus 2 plus or minus 1/3, since 1/3 is the square root of 1/9. And now you just add 2 to both sides, so you either get x as 6 plus 1 over 3 or 6 minus 1 over 3. So the answer is 5/3 and 7/3, depending on which side you take the x to. Finally, example 9, m squared minus m equals 2. Go ahead and try this one yourself. Remember, you can probably figure out how to factor this, but we're going to practice completing the square, so go ahead and do that. Alright, so you have it already set up for you. Now you add half of b and square it, so negative 1 over 2 squared, so it's basically the same as 1/2 squared. Add that to both sides. And so you get m minus 1/2 quantity squared equals 2 plus 1/4. Now square root both sides after you combine it. So m minus 1/2 is equal to the square root of 9/4, or plus or minus 3/2. So m is equal to either 1 plus or minus 3 over 2. So m is equal to negative 1 or 2. Now, you might have noticed that if you just subtract 2 from both sides and you factor, you will get m plus 1 times m minus 2 equals 0. So, this is just another way to solve a problem. If it tells you to complete the square, complete the square. If it doesn't, then you are free to solve problems any way you want. That concludes section 7.1. If you have any questions about how to complete the square, please ask me in class or on email.